Okay, so welcome back to another video. In today's video we have the following problem from the 1987 Putnam Exam, and this is question B1. And so the question is just very simple. It's just evaluate this definite integral from 2 to 4 of the square root of ln of 9 minus x divided by the square root of ln minus 9 minus x, and then plus the square root of ln of x plus 3 dx. So you might be thinking, square roots in the natural logs, that's a bit off-putting, and is this really going to be challenging? Well, to answer that question, it's not that bad, and you'll see why. Simply, it's just substitutions, and we'll be performing a u-substitution, and then we're going to do something that we're going to actually take a little creative approach from here, and I won't spoil the surprise because eventually you're going to see what's going to happen. But let's jump into it. So I'm going to define this integral as, I'll just call this capital I, and this is going to be equal to the same thing, the integral from 2 to 4 of the square root of the natural log of 9 minus x, and then this is divided by same thing, square root of natural log of 9 minus x, and then we add this with the square root of the natural log of x plus 3, and then dx. Alright, so what I can do is, of course, as mentioned before tackling this on, we're going to do a u-substitution. I'm going to call this y, so we'll call, we're going to let y equals 6 minus x, and then just perform the differentiation, so that means dy is equal to negative dx. Now, simply just replace the pieces back together, so that means we have that, we're also going to get our new bounds too, so we still have that this is capital I, of course. And then we have, this is going to be our new bounds, so if we plug 4 for x, we're going to get that the new bounds in terms of y is going to be 2. And then the lower bound, if we plug 2, this is going to be 4. And then we're going to replace, so we said y is equal to 6 minus x, so therefore this is going to be the new function as the natural log of y plus 3, and then this is divided by, so this is the square root of the natural log of y plus 3, and then add this with the square root of the natural log of 9 minus y. And then multiply by negative dy. Just substitute with the, we said the negative dx, but you just divide negative 1. And then just, of course, this is going to be the negative, so this is going to be negative. Well, okay. What I can exclude is I can just get rid of this negative, simply because not only that, since we have the upper bounds and lower bounds, the numbers are larger than the other, which that's not the case, so we had to actually switch our bounds. That replaces the negative and excludes that negative. So then we still have that I is equal to, so this will be 4, this is 2, and then we still have everything from this integrand over here, the natural log of, or excuse me, the square root of the natural log of y plus 3. Okay, and then right over here, same thing, y plus 3, and then add this with the square root of the natural log of 9 minus y dy. Okay, that's what we said, that I is equal to this and I is equal to that. So what's interesting here is that I can actually double the quantity of that. So this is basically 2 times I, right? And so we're just adding the two integrals together. They're under the same bound. Not only that, I can just replace x for here. This is simply just a dummy placeholder, so I could just replace x here. So then we have that this is the integral from 2 to 4, and then let's see. So we have the square root natural log of 9 minus x, and then okay, so same thing over here, natural log 9 minus x, and then add this with the square root of the natural log of x plus 3 dx. And of course we just add this with the integral over here. We could just replace the y for x, so this will be the the square root of the natural log of y plus 3, and divided by the square root of the natural log of, or that's supposed to be an x over here. That's supposed to be an x plus 3, and then we add this with the square root of the natural log of 9 minus x, then dx. Okay, now if I combine the sums together, then you'll notice that they share the same denominator. So I can just combine the two together. So let's see, 4, 2, then we have the square root of the natural log of 9 minus x. Then we add this from this numerator over here, the square root of the natural log of x plus 3. And then we divide this by our denominator. Remember, there's the same denominator over here, which is fine. So I'll just write this as the natural log of 9 minus x. Then we add this with the square root of the natural log of x plus 3, right? Okay, and then dx. Oh, but would you look at this? They shared the same terms, numerator and denominator. It cancels each other out. So therefore, this is just equal to the definite integral of just 1 dx. And so this is a very simple calculation. This is just from x, and then evaluate the bounds from 4 to 2. Then you'll see that this is just 4 minus 2 equals 2. But we're not done yet. Remember, 2 is equal to 2i. So we just and we're trying to solve this integral over here, which is we defined it as I. So lastly, simply you just divide 2 to both sides, and therefore you get that I, or this integral that we're being asked to evaluate, is just equal to just 1, like so. So yeah, nothing too crazy. I told you it wasn't going to be that hard. It's just very simple, right? Don't overthink things too much. So yeah, that's pretty cool if you ask me.